All right, let's do a little bit of review quickly because it's been a week. Talked about how to do select queries, and that's what we're doing in single table queries. Designate the keyword select, and then a list of fields. These all use star, which means give me all the fields from TBL student. But you can list the fields that you want in the order that you want them. Then you can designate criteria. Only give me the records where the student is full-time, where the student is not full-time. Okay, these are Boolean examples that we're looking at here. Remember, with Boolean, the easiest way is just to say the Boolean variable name or not Boolean variable name. So just as a quick example, I can say select from TBL employees where union member. Union member is a Boolean field. They either are or they are not. This select all. They either are or they are not. I can say equals 1. I can say equals true. It's really redundant. By just saying where they are a union member, we should get the list. Okay, there's the list. Notice all the union members are marked as 1. In the database, they're stored as 1. But MySQL can translate Boolean variables into true falses. You can also say equals 1. That works. But really, you should be, when you're messing with Boolean variables, just enter the Boolean variable name. If I wanted everybody who's not a union member, you can add the keyword not to the beginning of that. And now they're all zeros over here. I'm going to fly through the review. If you need me to stop, you got questions, ask. We then learned about the in operator. The in operator is used in the where clause. Again, the where clause allows you to restrict the records. Don't show me everybody. Show me the records where the color field, whatever that is red, white, or blue. This allows you to create a list of values that you want to match. If it matches any one of those 3 values, it will be included in the result set. If you have a color that's black, it's not excluded or included. You can put a not in front of this as well and say if it's not in this, which is basically exclude red, white, and blue. That's perfectly acceptable. The not keyword can be applied in lots of different places. We then learned about like. Like allows us to use a wildcard character. The percent sign is the most commonly used one to say anybody whose name looks like DAV followed by anything. The wildcard character represents anything, including nothing. Here's an example with the wildcard character in the front. Give me the names that end with SON. And one of the most common uses is give me the names that contain SON. Doesn't matter what's at the beginning, anything at the beginning, anything at the end. As long as it's got the letters SON in sequence somewhere inside the data, they will be included. There's also an underscore character. I talked about it briefly, but I rarely use it. So just as an example there, I think last time we said, give me all the information from TBL trips where the destination is like C. You can't stop there, because if you say like C with no wildcard characters, it's looking for exactly C. If I want any city that starts with C, then I have to put the percent sign in there. And I get the Chicagos and Clevelands, and if there were any Cincinnatis here, they'd show up. Coloma would show up, but all the database has is Cincinnati, or Cleveland, and Chicago. If we put a percent sign in the front, we might get a few more cities. I haven't tried this. I'm making it up as I go. But this says as long as the city name, the destination of the trip, contains the letter C, and sure enough, we get some more. DC, notice the C is at the end, the C is at the beginning, the C is in the middle someplace. When you put percent signs around both sides, you're basically matching a contains type statement. In C#, it's called contains. If it contains the letter C anywhere, give it to me. So percent sign on both sides designates. Questions? Talk briefly about R-like. It's not part of the assignment, so I'm going to skip that part. If you need to know whether any of the fields are null, you cannot say equal to null. You can say select star from TBL trips where the duration, we don't know how long the trip took, probably because we're still on it, is null. And I made a mistake. What did I do? Where? And didn't spell it right either. Where? And so there's some trips where the duration is null. Notice it actually says null. That's not the same as the empty string. It's not the same as 0. It's a missing, in this case, numeric value. Any field, based on your database definition, can be null. Most fields can be null, except your primary key. If I put an equal sign here, notice it doesn't work. Syntactically, it's correct. But I think null is kind of like a black hole, and it just represents, it just sucks everything up, and so duration can't be equal to it because duration doesn't suck up everything. So that may be what that implies, but if you want to check for missing data, you have to use is. You can also use is not. That's what the notes mentioned if you're looking for the ones that are not missing. Equals doesn't work. Equals the empty string here will not work. It might work syntactically, it won't give you any red squiggles, it'll execute, but you'll get the wrong answer. So be careful with that one in the homework assignment. Sometimes we want a list of values. For instance, if I want to know where have I gone and where have my employees gone on trips, we can say give me the destination from TBL trips. Let's just say period. Done, not period, semicolon. And we'll get a whole bunch of lists, and there's Dallas and Miami, and notice there's 2 Miamis and there's a Chicago. We could help ourselves here a little bit by doing an order by clause. That's coming up in the review next. It allows us to sort. The where clause, if you include one, like up here, if you include a where and an order by, the where clause must come first. The order by clause comes pretty much last all the time. Order by destination. That will sort them and keep all the Atlantas together and all the Cleveland, Chicagos, etc. But the boss might look at that and say, why do I have all these duplicates? I just want a list of the cities that we travel to. To do that, you simply add a distinct clause or a distinct statement to your field list. Normally, distinct is used when you have a single value, but it can be used with multiple values if we wish. But right now, if I execute that, it'll just give me a distinct list and all the duplicates are gone, and now there's my list of cities that I've gone to. My advice is run your query without the distinct first. If you're getting duplicates that you don't want, then add the distinct clause to it. Remember also, while I'm thinking about it, that on my website, for the homework assignment, I've given you the answers, right? You come down here to the assignments. Here's the single table queries assignment. These are the files that you need for Henry Books, Premier Products, Lexmark, Marina. Just import those. That's in last week's recording. But here's the result sets on my website. Here are the answers you should get if you do the queries correctly. Doesn't tell you how I got there. But if you get that answer, there's a pretty good chance you've got the right query, but sometimes some of you will put in a distinct when you don't need it. You'll get the right answer, but I'll see the distinct and say you don't need that here, you shouldn't be putting it in. Unless I think about it and say, well, I guess there could be duplicates. But if there's no chance of there being duplicates, then you shouldn't use distinct. We talked last time about the in operator, remember, in, red, white, and blue? You shouldn't use in when there's only one value you're comparing to. Give me a list of all the trips where the destination is in Chicago. That works, but that's not the purpose of the in operator. It's to make a list. Should be using equals or destination equals Chicago. It would be more appropriate. All right, so that's distinct. We just talked about sorting. By adding an order by clause, you can sort by one field. If there's a tie in the last name, comma, then sort by first name. So this will sort everybody by last name, but if I have Schmitz and Schmitz, then I get Nick, and then Sam. DESC is used for descending. meaning sort in reverse order. There's also an ascending, ASC. You don't normally use that. Primarily there if you're writing programs, you need to figure out whether to sort descending or ascending. I have never seen a real query out there that sorts ascending because that's the default. But if you want to sort in reverse order, largest number, amount owed to smallest, last name, or this is amount owed, largest to smallest, but then last name, first name, alphabetically A to Z. This descending only applies to the field that it's attached to. If you wanted to sort by last name Z to A, so that Jeff isn't at the end of the list all the time, right, we'd have to add another DESC here. You can do that. Remember, if you have a where clause and an order by clause, the where clause comes first. Typically, I'd put the order by clause underneath. To make my queries a little easier to read, I tend to break them up. If the select command isn't terribly long, then the from goes on the same line. If it gets long, I move the from down. The order by gets its own line. The where gets its own line. Makes them easier to read, easier to grade, keeps my sanity, which is good. I'm not quite so picky. All right, new stuff. In the database design course, we talked about how you never, or almost never, store in a database a calculated field. If I wanted to calculate how much, this is the I don't know if that's instrument cost or install cost, I guess it's an install cost, right, times a tax rate. Instead of having some human do that calculation and then type the answer into a cell, databases allow you to do calculations on the fly when you need them. So often you will not see, for instance, GPA at midstate is probably not stored in the database. Whenever I want to look up your GPA, I say, give me Tim's GPA, and behind the scenes, the database is furiously mixing all that stuff together, and poof, we get a 3.99997, just barely missed. Right. But all that gets calculated every time you ask for it, because the next time Tim completes a class, we don't want to rely on some human to go through, do those calculations, figure out his new GPA, and plug it into the database. We're going to let the computer figure it out because it should be more accurate. If it's screwing it up, then our formulas, our program is wrong and we fix it. But when you get humans into the loop, there's a good chance that when they retype it, that'll screw it up. When they type it into the calculator, they'll screw it up. They'll miss a class. All kinds of things to screw up. So we're going to let the humans do it. So we can create calculated fields. We do the math just like you do in most programming languages, using a plus and a minus and a star and a slash. And we can create formulas as complicated as you want them to be. Looking ahead into the next unit, multi-table queries, we can do calculations where one field is in this table, one field is in that table, another field is in this table. We can mix them together, come up with one number. In this unit, all the fields will be in one table. So if I wanted to, for instance, calculate, are those big enough for you back there, Carson? You can read this? Okay. If I wanted to calculate the cost per day, I can do that. There is no cost per day here. I have the trip expenses, and I know the number of days that they went on the trip, but if I wanted to know the average cost per day, I can do that calculation. So let's give me the select and the destination and the duration. Let's do expenses first, and the duration. And now I want something that doesn't exist in the database. I want a calculated field to display. You put them in your field list. And you show MySQL how to do the calculation. Take the expenses and divide by the duration. Order of precedence rules apply. Remember, multiplication, division gets done first, then subtraction and addition. If you want that to change, you can put parentheses around this. You can put parentheses around that anyways, just to make it more readable. From TBO trips. Go. And notice it does the calculations for me, and I can check this. Let's find one that's easy. 405 divided by 2. That looks right. It's kind of ugly looking. And if you're anal like some of your software developer friends, you might want to round that to decimal places. I'll show you how to do that. But remember, if you're a database person, digging around inside the database here, you're generally not generating something for human consumption necessarily. You're just doing data. Often this data then gets sent to Visual Studio, and in Visual Studio or PHP or whoever it is, that's where you format it before you display it. So the fact that these numbers have 6 digits in them after the decimal place doesn't matter. But just in case, I'll show you how to format them in just a second. So there's an example. I think I got some more. Here's a multiply. Here's an interesting thing. Give me all the fields, comma, and this calculated field. So you can mix the star in there if you wish. We can do any calculations. What else do I have over here? Calculate the trip per day, and that's it for now. Okay. So adding a calculated field, you just add it in the field list as a formula. What's a little annoying about it is hard to see in the recording because it's so tiny here because I've modified my resolution for recording. But what's hard to see here is what it does in the column heading is it puts your formula in there. Now imagine you got a formula that's this wide. Your column heading is going to be the entire formula. That's gross. How do I fix that? You can give it an alias, is what this is called. Give it a new name. By simply putting the new name after it, I don't like that because it gets blended with the formula. You can add the keyword as, and then the name, cost per day. So the keyword as is optional, but I think it improves the readability, so I recommend you put it in. And then when I run this, this says, again, it's kind of tiny, but it says cost per day. Jeff can read it, right? That's what it says. Calculations can be whatever you need them to be.